Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we're talking about nuclear radiation uses in medicine. So put down today's title, it's going to be Nuclear Radiation Uses in Medicine. Okay, and before we get started guys, make sure that you've watched my other videos before watching this one because you have to have a full understanding of how alpha, beta and gamma work and the properties of them. So, first of all, one use of nuclear radiation in medicine is going to be to sterilize medical equipment. So, sterilizing medical equipment. Right, so, obviously there's loads of surgeries that take place in a hospital and there's loads of stuff which is going to be used, medical scissors, medical knives. But obviously as you use them, they're going to, pick up bacteria. Let's say here it is, a big blob of bacteria over here. There we go, there's the bacteria. The key thing is this. Obviously you don't want to transfer the bacteria from patient to patient. So you've got to kill off that bacteria. Right, and one way of actually removing the bacteria is actually by blasting it with gamma radiation. So look, gamma radiation is being blasted at the thing here. So there we go. I'm just drawing some waves here so we can fire the gamma at it. So gamma radiation is going onto the bacteria, and as it travels, it will hit it, obviously. There we go, and it hits it, bang, over here, and it can kill off the bacteria, guys. So there we go, it can kill off the bacteria. So now guys, you have sterilized the equipment, guys. It is now clean to use. So gamma radiation is used to sterilize equipment. Right, so what are the advantages and disadvantages of actually using this method of sterilization? Well, they are the following. Advantages of sterilization. Number one, high temperatures are not required to kill off the bacteria. Number two, it can be used to kill off bacteria on things that would normally melt. So usually people would have to heat up the equipment to obviously kill off the bacteria. But now look guys, with gamma radiation, you're not required the high temperature and nor will the object melt now. Easy stuff. Disadvantages. It may not cover all the area, so the bacteria may not all be killed. So that's the key thing here. So obviously you're firing it from one side, it might not kill off all the bacteria. So you've got to irradiate it from all angles to kill it off properly. Second disadvantage, the risk of ionization radiation in the nearby environment. So obviously if you're using gamma radiation, guys, you're exposed to more ionization radiation, and therefore that can lead to a mutation in your DNA, and therefore can lead to tumors and therefore cancer, guys. So obviously, you have to take your precautions when using gamma radiation. Good, so we've done one use of gamma radiation so far, which is going to be sterilization. Now let's move on. Okay, so this is the second use of gamma radiation. It's going to be used in the gamma knife, guys, or the treatment of cancer. So what happens is, let's say this is somebody which has a tumor, let's say on them right now. The way that gamma radiation can be used is the following. So you want to target these cancerous cells inside the tumor. So that obviously the tumor contains cancerous cells. And the way to do it is this. If you were to blast it with radiation from all sides, gamma radiation, so we blast it from all sides over here. So let's blast it, guys. So let's just say there's a blast from here, a blast from there, a blast from there, and a blast from there. So they're all going this way, the gamma radiation here. So this is the gamma radiation. Right, and obviously where they all meet, they are concentrated and therefore they can kill off the cancerous cells, guys. So right where they all meet, that's where they can kill off the cancerous cells. So that's a key thing about the gamma knife, guys. So you are exposing the patient to gamma radiation, obviously, but the key thing is that it's only where they're all concentrated and when they're meeting, that point will kill off the most cancer cells here. Alright, so you might be wondering, what about the healthy cells inside the body? What about the healthy cells? Well, yes, look, the healthy cells will receive a dose of gamma radiation compared to before, but it's only the cancer cells in the target area which receive the highest dose. Only the cancer cells in the target area receive the highest dose, guys. So yes, you are exposed to more radiation, but the target area receives the concentrated amount the most. Okay, so that is the gamma knife. There's one more, guys, which is a bit more interesting. Alright, so let's talk about the medical tracer now. So here is the medical tracer. So sometimes, guys, we might actually need a patient to ingest a radioactive source. So we need to put a radioactive source within a patient. And you'll see the reason why in a minute. Okay, so inside the person, guys, we're going to place a gamma source. So here, we'll just put a blob here, just for diagram purposes. And so obviously this is going to be the gamma source. So the patient ingests a gamma source for a bit. and as we're going to look at the radiation that's going to be emitted from it. Right, so now the gamma source is inside the body. Then, if we were to leave it for a while, obviously the gamma radiation will be able to be emitted from the source. There we go. There we go. Gamma is being emitted from it. There we go. There we go. There we go. So gamma radiation is emitted from it. So after a while, at the start, there's loads of gamma radiation being detected all the way outside of it. But after a while, if we come back and we notice that one of your kidneys is still giving off gamma radiation. So one of your kidneys is still giving off gamma radiation. Well, the key thing is this. Obviously, because all of the gamma radiation should have left your body. But because this kidney is still giving off the radiation, what does that mean? Well, that means that there must be a type of blockage somewhere. So the key thing is going to be that there will be some type of blockage somewhere over here. So this bit will be the damaged kidney. So damaged / blockage of some sort. Wonderful. So as you can see, we have now been able to identify which of the kidneys has been causing the patient problems. The reason why, obviously, is because we put gamma radiation into it at the start. It's usually going to be emitted and should all drop down to 0. But now look, if you notice that one of your kidneys is still giving off gamma radiation after a certain period of time, you clearly know that is the damaged one because it probably absorbed more of the radiation. Okay, so once again from the top, patient ingests radioactive isotope which gives off gamma radiation. After a period of time, all gamma should have left the body. If an area is still giving off radiation after a while, this indicates a problem, and therefore you can identify which of the kidneys is not working properly. Easy stuff. Last of all, factors to consider when selecting radiation. So the type of radiation, alpha, beta, or gamma, needs to be considered. Right, so let's just talk about this in terms of the medical tracer right now. So the reason why I chose gamma here is because obviously I want it to pass out of the body. So that's the reason why gamma is chosen over here. So gamma can pass easily out of the body. And guys, obviously the reason why you chose gamma is because it is the least ionizing, guys. It is the least ionizing. Wonderful, guys. So look, guys, so the two reasons why. Obviously, you don't want it to be too ionizing inside the body, obviously, because obviously it causes you, to develop cancer. So the two reasons why I use gamma is because it is the least penetrating and therefore can pass through the body because it can pass through skin, and it is the least ionizing, guys. Right, there's one more thing we have to discuss. It's going to be the half-life, guys, the half-life of the actual isotope here. So if the half-life is too short, there won't be enough time to carry out the actual experiment. So if you were to place it into the person's body and it had a very quick half-life, let's say a second, after a second's gone, there won't be enough time for you to carry out the procedure. So that won't work. But if the half-life is too long, obviously it will remain in the person's body for too long, therefore exposing them to a larger amount of radiation than required. So obviously there's a Goldilocks zone, guys. There's a natural amount. So you don't want it to be too short, nor do you want it to be too long. So make sure that you understand that, especially in terms of half-life. And the last point is going to be toxicity. So obviously you don't place something into the body which is going to be toxic. So obviously that matters as well. Obviously don't put something toxic into the human body. Right, so recap from the top. Nuclear radiation uses in medicine. The first use is going to be to sterilize medical equipment. To sterilize medical equipment, you can blast the medical equipment with gamma radiation and it will kill off the bacteria here. Then I said the advantages and disadvantages of sterilization. And as you can see, advantages and disadvantages: high temperature is not used to kill off the bacteria. It can be used to kill off the bacteria on things that would normally melt. Disadvantages: it may not cover all the area, so some bacteria may not be killed. And also there's a risk of ionizing radiation in a nearby environment. Scrolling down, the gamma knife. The gamma knife is one use of the gamma radiation. If you have a tumor, they blast you with gamma from different directions. Where all the rays meet, that's going to be concentrated on killing the cancer cells. Obviously, your healthy cells receive a low dosage, but the cancer cells in the target area receive the highest amount. So that's going to be a use of the gamma radiation to treat cancer. Next one, guys, is going to be the medical tracer. In this, the patient ingests a radioactive isotope, which goes inside the person's body. This emits gamma radiation in all directions, and it should leave the body equally, guys. It should leave the body equally. But after a while, if you were to come back to it and you realize that one area is still giving off radiation, well, the key thing is that it must have absorbed more of the gamma source, and therefore that is the most damaged part. So there must be a blockage there. So if it's still giving off gamma radiation after the prescribed time, there's a damage there. Right, and last of all, we talked about the factors to consider when selecting radiation. The type, alpha, beta, or gamma, the half-life, and its toxicity all matter, guys. They all matter. Right, the reason why we chose gamma, guys, in the medical trace is because, have a look, guys, it was the least ionizing, and obviously it could pass through the skin to be detected, guys, because it is the most penetrating. So it was the most penetrating and the least ionizing, guys. And that's it for another session of CeerazzleDazzle Physics. Make sure you like and subscribe to get my channel going. I'll see you next time for more cool physics. Ciao, ciao, and goodbye.